Hi coders, welcome to my YouTube channel, and in this video we will going to solve the problem 766 Toeplitz matrix. So let's see what the problem description says. Given an m cross n matrix, return true if the matrix is Toeplitz, otherwise return false. A matrix is Toeplitz if every diagonal from top left to bottom right has the same elements. Okay, so let's see the example. So there's an m cross n matrix, and in this matrix we can see that all the diagonals has the same value. So if you'll see this diagonal, then it has only 4. If you'll see this diagonal, this has only 3. If you see this diagonal, this is only 2. If you see this diagonal, this is only 1. If you see this diagonal, this is only 5. And if you see this diagonal, this is only 9. So this is a Toeplitz matrix. Now we see the example 2. So if you'll see this diagonal, this has only 2. But if you see this diagonal, this has 1 and 2. So there are two different numbers. So this is not a Toeplitz matrix. Now let's see how we can solve this problem. If you'll see the second number from every diagonal, that should be equal to the previous number in the diagonal. So this is 4, that is only one number. So we don't need to compare this number with anyone. But this is a number in this diagonal, and we have to check whether this number is equal to this number. So this is equal to this number. Now we will check for this 2. This 2 is equal to this 2, and then we will check for this 2. This 2 is equal to this 2. So this is a diagonal. So we just have to check whether the element which is just one row and one column back to the current number. One row and one column back means I minus 1 and j minus 1. So for this number, the I minus 1 and j minus 1 will be this. For this number, I minus 1, j minus 1 will be this. So we just have to compare this 2 and this 2. And for this diagonal also, we just have to check this number is equal to this number or not. How will check? I minus 1, j minus 1 is equal to the current number. And for this also, if this number is equal to I minus 1 and j minus 1. And in this diagonal also we have to check the same thing. If this number is equal to the I minus 1 and j minus 1 of this number. This is only a single number, so we don't have to compare this number with anyone. So yeah, this is pretty straightforward. So we would just iterate the matrix dot length and I plus plus, and then this should be for columns. Okay, now we have to check if the number is greater than 0. I mean, the number means the indexes. So if I and j are greater than 0, then only we can compare this with their previous diagonal number. So if we are checking for this number, then we have to check this number with this number. But for this number we can't check anything because we don't have the previous diagonal value. So if I is greater than 0 and j is greater than 0, then if matrix I j is not equal to I minus 1 j minus 1, then this is not a Toeplitz matrix and we would return false. If we are getting all the numbers which are equal to their previous diagonal value number, then we would return true. Okay, now let's check if it's passing the sample test case.
Ouch!
Time limit exceeded. So j, okay, so here it should be j. Okay, so this is passing the sample test case. Now we will check if it's passing all the test cases. Yes, it is passing all the test cases. Now we will see what is the time and space complexity. So since we are iterating the entire matrix only once, and we are not performing any extra operations except for this matching operation with the previous diagonal value. So the time complexity will be order of m plus n, and we are not taking any other data structure for storing anything, so the space complexity will be order of 1. Yeah, that's pretty much it for this video. Thank you for watching this video.